All right, well, good afternoon, everybody. My name is Todd Frederick, and I am one of the founders of Cloudistics. And I'd like to thank everybody for taking the time to join us for our UK-based webcast today. We will be talking about the rise of the cloud and introducing our Cloudistics Ignite on-premise cloud platform. And we'll be doing a little bit of a PowerPoint presentation for everyone to take a look at. And then we'll be jumping into a live demo, so you can see the technology firsthand. And at any time, if you have some questions, feel free to post them in the chat button, and time permitting, we'll get to them at the end of the presentation. Or if we don't have time to do so, we will respond via email. So I want to say thank you for everybody for attending today. As we go through, first off, we do have prizes, and the marketing must be served. So we will be giving away 2 free tickets to Harry Potter's Fantastic Beasts movie. So we're excited to give those away. Those will be chosen at random later this afternoon, and you'll be notified via email. So, stay tuned. Hopefully you'll find the content to be exciting. So let's go ahead and kind of start a little bit when we talk about cloud options. And one of the chief concerns we hear from our customers and prospects is how to deal with the ever-increasing complexity and the cost associated with existing IT infrastructure. Oh, I'm told I'm not showing my screen. So therefore, let's do that. So thank you for that, Tessa. So when we talk about the cloud, it's really kind of become a SaaS-first mentality, or companies are looking to lower the complexity of their IT infrastructure, and they're looking to the public cloud to do just that. And some of the advantages of the public cloud, as you know, it's hosted off-site, so you don't have to deal with the hardware and the infrastructure. It's really pay as you grow. You can add and scale resources both up and down, so you have a little bit better cost control over the infrastructure. And it's really designed to be very simple, easy to use and deploy applications. And I would say that simplicity is one of the key drivers. So, in this presentation, we're going to look to see how you can gain the benefits of the public cloud, but on-prem. Some of the benefits also include things like, Agile application deployment, where we're seeing, where IT doesn't respond quick enough to the needs of the business, where a business owner has a credit card and starts developing and putting applications in the cloud. All of a sudden you have this shadow IT department. So Agile IT is very important for the IT administrator today, so they can deliver those applications very quickly to their customers or end users in that case. And so the other thing that we really want to be able to focus on is how we can simplify the complexity of the IT experience on-premise and give you that great level of performance that you're kind of used to with an on-premise infrastructure. So let's kind of focus just for a moment on some of the downsides of the cloud, because there's lots of advantages, but a couple of things we should really focus on. And first, let's just be clear. The public cloud is here to stay, and it makes perfect sense for a certain set of applications and different types of workloads. But what companies are finding out, it's not necessarily the panacea they thought it was, especially when it comes to complexity and performance of their applications. One of the things that we see is ballooning costs. For example, we hear many stories where applications were quickly developed inside the cloud, and when you move from a development workload to kind of a production 24/7 workload, the price increases rather exponentially. So those cheap resources become very expensive once they run into production. In fact, one of the founding reasons behind Cloudistics had to do in a previous life where we moved our entire QA and test and dev labs into AWS. And quite frankly, literally within 3 months, the pricing had ballooned to a point where we could have acquired 100% of the infrastructure had it hosted for just a couple months of usage fees. And the other thing is there's a little bit of confusion in the pricing of the cloud. You have the difference between a 3-year, committed price where you're buying all 3 years of compute up front, or what a lot of people seem to gravitate to is the IT spot-based pricing, which doesn't necessarily guarantee performance and availability for your applications. And then who controls what is running in the cloud at what time? We even had a CFO at one time come to us and ask us if we could help develop a tool that would automatically turn off certain applications on the weekend, because the developers would leave them running over the weekend and it was impacting their bill rather dramatically. And so there's also a lot of hidden costs that you see, puts and gets of accessing your data up in the cloud, and that makes it difficult for data-intensive applications. Now, when it comes to compliance, we all know that regulations just can't keep up with IT. They never have, and they're always a little bit behind. But these impact things like banking and financial institutions and even healthcare institutions much more dramatically. And for them to be able to keep up with the latest regulations and how it applies to where data is stored, who has access to data, the result is the public cloud just doesn't work for a good chunk of their applications, and they have to continue to run their applications on premise. Now, the other thing that we should talk a little bit about is uptime and SLA. And a lot of the people that we talk to have pretty stringent SLAs built into their application delivery schedules, and they're even compensated on those SLAs. When you move to the public cloud, you really don't have control of those SLAs. You, for example, get discounts if the cloud fails to meet them. For example, you get a 30% discount if Amazon fails to deliver 99% uptime. I guess the question I would ask you, if you were to deploy a mission-critical application, would 99% availability meet your business's SLA? And a lot of times we hear the answer is no. The other thing that has a little bit of an issue is what type of applications are you looking to move? As we kind of indicated, big data type applications have a difficult time being moved into the cloud because they're impacted dramatically by network latency. And what kind of network pipe do you have to get the data up to the cloud and back down to the cloud? Where's the source? What's the source of the data? Where's it coming from? And how does it get communicated to those big data applications? And we'll talk a little bit about that further in the presentation. And one of the funny things that we've heard in the last couple of years since we founded Cloudistics is this new word called unclouding. In fact, a quote from TechTarget's Search Cloud website kind of puts it as, well, let me just read it. It'd probably make the most sense. Customers cite a number of reasons for wanting to uncloud. Factors include security issues, liability concerns, difficulty in integrating cloud-based applications with on-premise enterprise applications, and data. Frustrated expectations with respect to the cloud's cost efficiency may also include and influence declouding decisions. Anecdotal evidence suggests that customers citing cost as a factor may elect to move applications to an all in-house or hyper-converged infrastructure as the better economic choice. So we are in that hyper-converged space with our Ignite platform. In fact, it's a little differentiated. We go as far as to call it super-converged. So let's take a jump and look at what is Cloudistics. So essentially, and simply put, it's a complete on-premises cloud. It contains everything you need in a simple plug-and-play appliance to stand up your own cloud computing platform. Think of it as a private AWS that you can reach out and touch. You can feel it. And on average, you can run applications, very highly performant applications, at about a third of the cost of a traditional AWS or Azure platform. The technology and the hardware itself is modular in design so that it can independently scale both storage and compute resources as needed. Typically, when you look at a hyper-converged solution, they're bound together, right? And so it's kind of a one-size-fits-all configuration. Now, you can choose how much compute and how much storage, but they're always bound and they have to replicate to one another. The way we've architected this solution, it's completely independent, and you can add resources completely independently. So if you have a very CPU-intensive application, you can simply add compute. If you have a very storage-intensive application, you can just add storage and completely grow them independently and on demand. And similar to the public cloud, we have the concept of what we call Ignite's Cloud Controller. And the Cloud Controller provides a single pane of glass to manage the entire platform. All aspects of the data center can be managed by any IT generalist. You simply use the controller to define storage, define your network, and deploy applications literally in minutes, just like the cloud. It proactively integrates with the hardware as well and proactively monitors the hardware health. So it'll actually even alert you to potential problems that may be occurring in the hardware. So again, this single pane of glass does application deployment, network storage configuration, virtualization, as well as proactively manage the hardware infrastructure. And it can be, it's delivered as a SaaS-based portal. However, you can also bring that SaaS portal on-premise for additional security purposes, so you can have the best of both worlds. Because it was designed for performance, we use an all-flash storage array. And we use our innovative software stack to kind of take that and virtualize that storage layer. And because of the way we've done this in software, we're actually seeing performance about 5 times greater at the application level when we talk about IOPS and performance. So we're getting 5 times the IOPS at the application layer than a traditional VMware-based or Amazon-type cloud. So you can really drive a lot of performance for a really low amount of dollars. And the other thing that a lot of people seem to like about the technology is it's a very dense server and storage footprint. And the idea that because it's very dense, you can run it in a very small amount, don't need a big amount of data center space, and it all goes to the safe space. It goes to the savings that you get from deploying this type of application. But let's take a look a little bit more at the performance because they're pretty impressive. So you can see here we can deliver over 30,000 IOPS per virtual machine itself. And we can aggregate that performance over to 200,000 IOPS across our 2U storage block running at 96 terabytes for a single storage single storage block. Now the hardware itself is fully redundant and the storage block has fully redundant storage controllers. And in addition to adding resiliency to the platform, the fact that we deliver redundant storage controllers assures you that as you grow your storage or add additional storage blocks, you get linear scaling of performance. So what happens is when you want to go beyond 96 terabytes of all-flash storage, you simply acquire another storage block. It has the dual controllers on it, and again, you get that linear performance, and you can add an increment, any increments that you want, but up to 96 terabytes of all-flash in a 2U, right? And you can guarantee that as you add storage, you don't degrade performance, which is very important. And also, when you look at the scalability of the cloud platform, we pool all these resources together, the compute, the storage, and the network, and the memory, into a single elastic cloud that you can then carve up for your applications, your end users, or different departments. And you can give these carve-out pools, or we call them virtual data centers, you can give each of these departments or end users or application a slice of the private cloud that you've built. So just kind of moving on, to sum up what makes it better, faster, and stronger than other solutions, oops, I think I went one slide too far there. Here we go. Sorry about that. Live presentations. So to sum up, first we deliver everything in a plug-and-play infrastructure. With the cloud controller itself, when you first plug it in, self-detects, registers the hardware, configures the entire appliance, and you're literally up and running, ready to deploy applications in minutes. In fact, there's a demo on our website where we can show you we can instantiate the unit and deploy an application in under 15 minutes. We virtualize everything into this pool of cloud resources, these elastic resources. So compute, memory, and storage, and more importantly, the network that binds everything together are completely virtualized. And this allows us to deliver simplicity of management as well as optimized performance and scaling, right? You can grow the cloud just like you would in Amazon, add resources dynamically. The cloud controller allows me to manage any component of the cloud from anywhere. It's a simple single pane of glass, right, that allows for management of not only just the individual appliances, but multiple appliances, even across multiple geos. So I can have a complete single point of contact, single pane of glass interface that multi-geos and multiple data centers, anywhere I have internet access. Whether it's in the SaaS, using the SaaS portal or the on-premise portal, you get the same functionality, right? So you can manage this entire infrastructure from the beach if you so desire. Now, the other component, to enable to deploy applications in minutes, we have a concept similar to Amazon of an application marketplace. And inside this marketplace, you can download the latest applications and virtual appliance literally with minimal configuration. They're already sysprep, they're ready to go. You download, you instantiate. If they're a Windows license, you put your enterprise key into it, and you point, click, and deploy. But you can also create your own master marketplace by converting any VMDK, VHD, or ISO image into a running virtual machine. So it works with all your existing VMDKs and existing templates. Now, the other thing is application performance is a must, and the demands of applications are doing nothing but increasing, especially in the big data type application arena. And we we do our network virtualization at line speed. And what does that mean? Well, that means we have a backplane of performance where we can move data across the backplane of this appliance at over 1.544 terabits per second. And we write that data directly to a flash block storage array with no intervening file system. It's part of the unique storage and part of the cloud components that we use to make sure that the product delivers exceptional performance. The Cloudistics' modular approach really allows us to scale this appliance on demand. So you can dynamically add compute and storage to a running system. So if you needed to go from that 96 terabytes, or you could start at 12 terabytes or 3 terabytes, for example. And if you needed to go from 3 terabytes to, let's say, 9 terabytes, you can add that storage to an existing running system and grow dynamically. There is no downtime associated with adding storage or adding compute. And we take that even to a next level where we can actually dynamically insert additional CPU and additional memory to running VMs. So you can actually run and grow VMs online without downtime. So imagine that, you have an application performance issue, you need a little bit more of a boost, you don't want to take down the application, dynamically insert additional resources to the application, and let it rip. So what's the real secret? What really ties it together? And it's quite simply, it's software-defined everything, right? And it's really, when you look at Ignite, it really is the first truly completely software-defined data center appliance. In 6U, you have everything you need to start deploying and running applications. And it brings the server, network, and storage disciplines under a single management console and finally eliminates those silos that have been prevalent for so long inside the data center. And it starts with our network virtualization layer. We're the only hyperconverged solution to build in true network virtualization. And when we talk about virtualization, it's true virtualization and not to be confused with orchestration, the ability to simplify the management of the network. It's real virtualization because we can define all the software network rules completely in software and then apply virtual machines to run inside those VNets, right? And this allows us to get all the benefits of network virtualization, things such as microsegmentation of all your traffic, distributed firewalls across the networks, integrated DHCP microservices. So you have this capability of really defining the network in software. The other component is, because of the way we virtualize the network, it can work and communicate beautifully to your existing network infrastructure. All we need is an IP address and a couple of ranges and a route path to your existing network. And this infrastructure can set up directly next to your existing infrastructure and work seamlessly across both. The second thing is our hypervisor. So Cloudistics runs our hypervisor. It's a KVM-based hypervisor. And we chose KVM because it's at use in hundreds of thousands of sites, powering some of the most powerful web-scale sites on the internet, including Google, Apple, Amazon, for example. And we deliver the ability to scale in real time, as I mentioned, by adding CPU to an existing system. And that's a great feature, and a lot of customers like that. Additionally, KVM has some of the highest spec mark ratings in the market. So it's one of the fastest proven hypervisors, again, in the space. So again, it delivers fantastic performance, which is one of the tenets of our solution. The cloud controller, as I mentioned previously, delivers a single and smart management console that combines all that hardware and software management into one single interface, making it very easy to use, and a lot of intelligence. So the SaaS controller also looks and monitors the health of the hardware or health of the application. And if there's anything that goes on with it, we can proactively alert you. So again, it's an interactive and proactive management console. And finally, we software define the storage. And one of the ways that we do that is we deliver raw block disk performance on top of an all-flash array. So you get all the features and the performance benefits of direct block storage, as if it was running local storage with thin provisioning and application-aware snapshots. So again, you could think of this as you get all the features and benefits of direct attached storage from a performance perspective, but with all the features you've come to know with SAN-based storage, with snapshots, etc. So when we look at some of the use cases for the cloud, essentially wherever you have a need for infrastructure, Cloudistics can play a role. We deliver exceptional value and performance for the applications that need it. So whether it's deploying a new application infrastructure or improving the performance of an existing kind of troublesome application, this is a great platform. A lot of customers that we've been speaking to, have a mandate to look at cloud first, as I mentioned in the beginning of the presentation. This can give a great way to kind of get that cloud experience to reduce the complexity of the management infrastructure, all while lowering the cost and delivering that on-premise cloud experience. Also, if you're looking at hyper-converged solutions today, this is we're calling it, again, super converged, but also for hardware refresh and data center consolidations, it's a great place. So let's talk a little bit about some of the application side of it. One area in particular where, an on-premise cloud makes, and it just seems to want to click twice. So one of the areas where an on-premise cloud makes the most sense was where you have a lot of data being manipulated. And of course, big data is kind of a hot topic right now. You can see MapR, Hortonworks, Splunk, Cassandra, Cloudera. A lot of companies are looking at these applications to do a lot of data processing. And in this, where there's a lot of significant processing, they're not necessarily great for the public cloud, primarily because of the cost of cloud-based SSD storage to get performance, as well as network latency. So it can become very cost prohibitive to run these types of applications in the public cloud. Also, the type of data that may be being sent is something that may be, it's kind of strategic to the company and may want to be kept on site. Now, what's interesting is our application marketplace that I mentioned earlier is already up to date with the latest versions of these applications. They're sysprep, they're ready to go. They're already on their optimized operating system. So we worked with Splunk to define, a great Splunk experience, for example, and we found that there's a specially tuned kernel of Ubuntu that runs Splunk faster than any of the other Linux-based operating systems. So that's already configured up in our marketplace. You can simply download it and start deploying Splunk very quickly. Essentially, when we see a lot of some of these big data type of applications that are currently on-premise, we're seeing a lot of bare metal installations, right? Because bare metal is a great way to deliver on the performance, especially in Hadoop, for example. However, the complexity of managing the physical servers compared to managing a virtual server is exorbitantly different. So one of the advantages that we have with our network and our performance is we actually give you 3 times the performance of bare metal with all the benefits of a virtualized infrastructure. And we actually have a third-party white paper where we can demonstrate that we can run a Splunk environment, for example, literally 3 times faster than you could on bare metal because of the way we network and communicate the data. And you can download that from our website and see that kind of third-party validation. The other thing is it really helps to drive the simplicity and the cost effectiveness of what we're doing. The other, more specifically, let's talk a little bit about Docker. So we partnered with Docker to let's see why this is moving to the next one. Sorry, gentlemen. So let's take a look very quickly at Docker. And Docker was really built for the cloud, right? It's designed to scale on demand based on the needs of the application. So it performs really well in a cloud type environment, especially the public cloud where resources are quote unquote unlimited, where you continue to grow. And the other component is the application portability of Docker, right? It really makes it nice because you can pick it up, move it, from cloud to cloud, or even put it on a kind of a bare metal infrastructure. It really makes infrastructure invisible. So again, by partnering with Docker, we were able to enable our cloud platform to directly integrate with their management fabric, including support for persistent storage, networking, and complete container orchestration through their Swarm software. And so let me give you an example, a particular use case. We're working with a large financial institution who's looking to containerize, that's their word, some of their legacy private wealth type applications. And while the nature of their industry really precludes them using the public cloud for those types of application, they've done some of their preliminary development, the early testing and proof of concepts in the public cloud. And so the DevOps teams have the infrastructure to go ahead and start deploying these applications. Well, as they move those in, deploying this type of infrastructure on bare metal will be somewhat of a nightmare for a large financial institution that's really geared towards a more virtualized environment. So we're able to actually take those containers and pull them out of the cloud and run them natively on our Ignite platform with zero change. And because there's zero change, from the DevOps perspective, nothing has changed. They're very happy. They're able to migrate their containers from the public cloud directly to our platform, save money, as well as deliver a better experience to their end users. So let's make sure I got that. So the other type of thing, application we talked a little bit about, is we talked a little bit about Splunk and Hadoop, but essentially big data applications, it's all about ingest. How fast can I bring the data in? How can I ingest it, analyze it, make sense of it, and spit the reports back out? Well, quite frankly, with 30,000 IOPS per VM and a really fast backplane, we can do that very quickly. In fact, if you look at the price of Ignite relative to the cost of a traditional infrastructure to download or ingest 10 terabits on a daily basis, I know that's a lot. We're about a third of the price of just the hardware alone, not to mention the software. And again, we can run it much more quickly. And because it's already pre-configured in the application marketplace, you can simply download it and deploy it, right? And again, you have a single pane of glass. So we're seeing the Ignite Cloud actually function as a Splunk or Hadoop appliance, if you will, because of the performance, the simplicity, the plug-and-play nature. So instead of having to go through the IT infrastructure team to carve out SANs and set up LUNs and all that stuff, you can simply bring the unit in, plug it in, and be operational in relatively no time at all. So that's enough of me talking. What I'm going to do right now is I'm going to hand the demo over to Karin. Karin will show you how the cloud works, and we're real excited to show that. Let me set that up for you. Here you go, Karin.
Okay, thanks, Todd. So hopefully everyone can see my screen. Please, one of the hosts, let me know if you can't. So Todd's already talked about the ideology around what we're trying to achieve and some of the technology we've put in place to achieve that. So one of the things he talked about was fast deployment of the infrastructure itself. So you take a 6U appliance, if you will, roll it into a data center. It comes literally in a flight case on wheels. You can literally roll it into a data center. You plug it in for power, plug in network, give the switch, the lead router, an IP address, and then you walk away from the hardware. And then after that, the only time you need to physically touch hardware is if you're actually increasing capacity for storage or compute, or even networking in this instance. And then you go to our Ignite controller portal. You log in with your account, and this is the first thing you will see, a virtualized redefinition of your hardware infrastructure. At the top we have our switches. In this demo there's only one switch, but in a deployed environment you would have two. And then your blades and your storage controllers are dual homed in that instance. But essentially you have your network components at the top. We've got our compute. This is a 2U compute block that's capable of hosting 8 blades, of which we have 2 currently. And then we have 2U of storage. And again, in this configuration, 9 terabytes of usable storage, but that can grow, as you've already heard, up to 96 terabytes in this 2U chassis. So this is our physical hardware world. Having got our resources registered, it all auto-populates, and you get this great view in your switch of what's connected to it. So I can see immediately that I've got blade controllers connected here, storage controllers connected here, my management network, and my interconnect to the host network, so your internal network on this particular port here. And there's plenty of room for growth when I'm adding more compute chassis and more storage chassis. So when we have this composited, we can also see immediately the metrics of our hardware world. We can see the health of our fans, our redundant power supplies. We can even see the usage in BTUs of the actual complete chassis. So as we populate, we'll see these figures grow, and we get immediate evidence about the levels of performance and the levels of economics, I guess, of the hardware infrastructure. Once that's defined, that's it. We don't need to worry about hardware again. Everything we do is now software defined and controlled through software. And the first thing we want to do is take our pool of resources that we have here, and that is we have 2 blades that are giving us 64 cores and 256 gigs of RAM in this particular configuration. And so we can slice and dice those up as we like. And the first thing we do is recreate a virtual data center. Todd's already alluded to this, and I'm going to create one for you now. So this will be our BDC2 as an example. And then I need to allocate a selection of those resources. And I'm going to just give this one 20 cores, 32 gig of RAM, and I'm going to allow it to have 4 terabytes of storage. Save those allocations, and that's it. I've got a virtual data center defined, and I can now immediately start deploying applications. It's that simple to slice and dice physical resources into the virtual world. Now, from the point of view of a virtual data center, you can view that, depending on your type of business. If you're an enterprise business, you may view a virtual data center as a business unit. If you're a service provider, you may view a data center as a customer. But you may also view a data center as an application. So if you've got a large application like Splunk or Hadoop that demands huge amounts of resources, you may actually be deploying Cloudistics Ignite just to host that one application. And then you may set up 1 or 2 virtual data centers and then have those defined to give you, I guess, pre-allocated resources to grow those applications over time. And you can move those resources around as you see fit. So for example, in our virtual data center 2, if my 20 cores are not enough and I see that these graphs are starting to fill and reach 90, 100%, I can very quickly add new physical resources and apply them to the virtual world by simply changing my allocation. I can see here my virtual data centers, and I can quite literally come in here and change my number of cores to 30, save that, and now my applications have more compute resource available to them. The next thing we want to do is create what I guess you would envisage as a security zone around the applications I'm going to deploy. So because we live in a virtual world that's software defined, there's no more physical boundaries for security. So VLANs are gone. They don't exist in this platform. We use VNets, which is groups of IP addresses that have a similar security profile built around them. And the way we do that is we just go in and we create a simple VNet. And I'll create a new private VNet. I'm going to give it a name, and I'm going to call this our dev VNet. And then I'm going to deploy or specify the IP addresses that are going to live inside this VNet. Now, in this particular instance, what's actually going to happen here is it's going to auto-populate a DHCP service so that I can deliver those IP addresses to virtual machines as I create them. And we don't have to do that, but in order to expedite this demo, I'm going to do exactly that. So I'm just going to give this an IP range for my DHCP services, but also for the VNet specifically. And then as I do that, I then need to determine where that VNet is going to be situated, and I'm going to apply that onto my virtual data center that I've just created, VDC2, and then it's going to require, if we're deploying these microservices like DHCP or NAT or load balancing and indeed firewalling, which I am going to show you, I need to take some resources to do that. So all of that is all going to auto-populate. I'm just going to allow that to continue as is, and I'm going to create that VNet. And it's that simple. So a set of security protocols can now be applied onto that VNet. I haven't done that yet, but I can create firewall rules specifically for that VNet. I can create individual exceptions to those firewall rules for specific applications on specific virtual machines. And I get infinite flexibility in terms of how I populate and aggregate those security profiles. Now, the interesting thing here, and the important thing here, is that these profiles exist inside our Ignite platform, but my virtual machines still have standard IP addresses that come from the core network. So the ACLs out in your core network still apply to traffic as soon as it leaves our platform and it's heading out to other parts of your infrastructure or out to serve the public if you're running, for example, an e-commerce website. As soon as that traffic hits your network, all of the standard ACLs that you already have defined are in place. They don't get overridden by what we're doing here. So it's very quick and very elegant. So with my VNet defined, I now have a place in which to, a security zone in which to deploy my applications. And as Todd's already mentioned, applications in our platform are all built on virtual machines, and virtual machines are all built from templates. There is no concept of a freestanding, self-standing virtual machine that is not built from a standardized template. And the reason for that is that we want to be able to do excellent things like snapshotting in smart ways, single instancing of virtual machines, and it helps when we start to do DR and replication from site to site, and I'll talk about that in a little while. Now, when we deploy templates, we can create a template from an ISO. We can actually create it as if we're building a bare metal machine. So we create a machine, we install an OS, we install an application, and then we turn that into a template, and that gets used to instance virtual machines. I can just as easily go to a Cloudistics marketplace and download all of the latest apps already optimized on the OS that the developer prefers for optimal performance, and already in a configuration that's ready to run with minimal configuration from you, the end user. And from our marketplace, I just select one to download. And when it's downloaded, it's stored locally in your Cloudistics Ignite platform. And then you can start to do some fancy things with it. And I'll talk about that as we progress. But the first thing we want to do, perhaps, is start a new instance. And so I'm just starting up a web server here. And this, you can imagine, may be the front end for a large web application you've got, or local lab that you're setting up, and just want to apply some web services from. But because this is a template, I can use it to do some clever things. For example, I may want to deploy multiple versions or multiple instances of this particular VM and then configure those up to provide better performance or better scaling for the application that I'm going to create. I'm going to create 2 of these for this particular example. And then I apply that template to a virtual data center. So this is where my resources for these virtual machines are going to come from. We only have one flash pool, one storage block here, so it's pre-populated. And the disk is already defined as part of the template that we created previously for this particular build. The resources it's going to get by default are shown here, 2 cores, 2 gigs of RAM for each virtual machine. I can change that right here, or I can change that later when the virtual machines are running. As you already heard, we can do that in terms of applying hot plugging CPU, memory, and storage to a virtual machine. The next thing I need to do is decide how I want the machine to be provisioned and controlled in the network. And as you know, we've just created our dev VNet, and I'm going to put it in there. I'll talk about firewall overrides in just a second. The next thing we do with our instances is we determine whether or not we want them to start straight away. So if I'm deploying 10 front-end web servers, I may actually not want them to start up because I may want to go and change some configuration to optimize how they're going to load my mid-tier or back-end databases. And then I can also determine for these virtual machines I'm creating whether I want HA, which is the ability for them to migrate from physical host to physical host should the physical host that they're living on fail. So I'm going to enable all of that, and then I'm going to start these up. And when you start up virtual machines from a template, the very first instance that you create from a template will take about 50 seconds to deploy, and every single one that you deploy after that from the same template will take about 20 seconds. So these couple here are going to take about 50 seconds to start up because they're the first ones from this template in this VDC. But I'm going to switch to one of these other ones and just quickly show you how you can quickly allocate new resource to a running virtual machine. So this is my view of the resource consumption of a virtual machine I've created. Again, it's got 2 cores, 2 gigs of RAM, 180 gigs of storage. And what you see here, not very populated, are the metrics for that virtual machine that are stored per minute for 1 year. So I can see over a course of 12 months all of the CPU load as it's changed over time on this virtual machine, the memory loading, also the network bandwidth consumption, but I can also see physical storage capacity and the performance of that storage for this virtual machine. And that gets aggregated up from this virtual machine to my application and then to my virtual data center so that I get a holistic view as the further I go up the hierarchy of everything that's happening below, and I get all those same metrics all for the same time periods, and I can change them very simply and focus in on what I want to see. So I can get very good trending and manage my capacity in a better way. Okay, I'm going to go back to one of those applications. And as my application is already running here, if I need to define more resources for it, I can simply go and change my resource profile, as we did with the virtual data centers. It works in exactly the same way. And now I can say, well, actually, you know what? I need to give this one way more resources because it's a high-performance application, and I perhaps might want to give it some more storage. And I'll just go with the default there. And it's as simple as that. I can come in here, save my profile, and those resources are hot plugged into the virtual machine and from the virtual machine into the running operating system. Now, an important point to note there is obviously whether or not those virtual resources actually get plugged to the OS and therefore to the application depends on whether the OS can support hot plugging. Now, every version of Linux from, well, forever supports that, but in a Windows world, for example, you need to have Windows Server 2008 release 2, not 1, and anything after that pretty much supports hot plug into the Windows world. And there we have our new resources allocated, and if our application is running and demanding more CPU, it will be given that CPU and that memory by the operating system as it requires. No outage in the application, no pausing of the virtual machine either, which in other platforms you would have to do, especially if you're adding storage, because you need to have a method to connect to a new iSCSI LUN. In this platform, you didn't see me do anything with storage. You're not even aware of the storage that's living underneath, and yet I'm able to add that to a virtual machine and to an application. We do all of that for you. No SANs, no LUNs, nothing. So we've got an application deployed. We've got resources that we've been able to add to that. And now when I was talking about our VNets and security, one of the things that I showed you was creating this VNet and adding virtual machines into that VNet. What I'm now going to go and do is create levels of security around that VNet. So I've already got applications up and running. I've already got them defined inside a VNet, and I can simply go and create a firewall rule, which I've already created here, profile A, and you can actually view what that rule is. And all that simply does is say that local machines are allowed to talk to each other and to nothing else. So in this instance, I'm creating what you might consider to be a closed lab environment. And that's quite an interesting concept, because in this platform, when I create this profile and I implement it, update settings, it will apply that profile to that VNet, instantly applying the controls to every VM that's in that VNet. And then that's it. They now live in a closed world. But the interesting point here, I'm just going to go back up to our hardware view, is that that VNet is living on one or other of these physical hosts. So if my virtual machines are running here, my VNet is deployed here on the hypervisor. So all of the traffic between those virtual machines never touches my switch. So if on this particular blade I've got a production application running, it's got all of the lovely network bandwidth that we give it, which is second to none, and I know that it's not going to be impacted by the lab environment I'm running, no matter what I do in that lab. So I can now, pretty much for the first time in a strategic way, deploy big applications, deploy test and dev platforms in one environment, managed securely, with full knowledge that everything I do in my test and dev will never touch or impact the stuff I do in my performance, in my production world. And so I can have a single platform to do all of those things I do. So, you know, one of the things that public cloud is used for is that very dev test environment where you want to quickly deploy services, you want to give control of those services and those virtual machines, the security of the network, to your test dev guys outside of the control of the main organization and the security teams there. And so the public cloud is a perfect place to do it because it can't possibly impact your network. Well, Ignite is a cloud, and you can do exactly the same thing with this. I've already mentioned monitoring and stats at the virtual machine level and at the VDC level. We also have the capability to go all the way up to look at an entire platform. And if you have multiple deployments of Ignite across multiple sites, you can get a similar view across all of your estate, geographically dispersed wherever it might be, and get a holistic single view of the health of the entire environment. All of the resources that I have in total, how they're deployed, where they're consumed, and what the capacity is of those resources that are being consumed. A very quick, very easy view. So that's it in terms of this very short, quick demo. We do have virtual labs that we can actually make available to you, so you can do exactly as I've been doing and get on and play with the resources, define resource virtualization, define your virtual data centers, deploy applications, play with those applications, look at how the system works with those applications. You can do all of that yourselves, and we can give you time on our virtual labs to do that. Obviously, you know, this thing is based on hardware, and where that need arises, we can actually deploy hardware to site to do POCs, for example, in institutions that require something that's not necessarily hosted outside of their security perimeters. So we can do that as well. So on that note, I will hand back to Todd for a couple of the final slides and for the prize draw.
Great, thank you very much. All right. So hopefully you guys should be able to see the Cloudistics Ignite 2.0. So just to let you know, we're always working on new features, new releases, and a lot of the features and releases comes from our customers and our prospects that we talk to. And you know, it's our goal to continue to make this a very robust platform. One of the advantages that we have with the customers who utilize the SaaS-based portal is that these new features just appear in their data center, you know, and that all of a sudden they'll be able to do things that they couldn't do before. We have a very extensive notification program that lets people know what's coming. But let's take a look at Ignite 2.0 that should be released right before the end of this year. We've added some new application orchestration technology so that you can have dependencies of applications and startup orders, and a little bit deeper systems control, right? So you can define how applications spin up, especially when you have multi-tier applications. Again, performance is always critical. We've implemented a faster networking backplane that allows us to do multipathing and channel bonding across multiple redundant network components. So that gives us an even bigger pipeline. So you'll see performance numbers actually increasing as a result. We're also going to be announcing a top-of-rack 100 gigabit top-of-rack switch in the very near future, probably right after the 2.0 release, but just to let you know that we're always thinking ahead. So you'll see more of a leaf and spine type architecture as customers look to blow this out and manage petabytes of storage, not just terabytes. Implementing new and enhanced disaster recovery technology with snapshot scheduling for all the VMs that are running, integrated replication, so you'll be able to have multiple clouds redundant to one another and be able to fail over from site to site. That really enable very fast recoveries, even bring in-house some of the routine kind of backup technologies directly into the platform. Incremental forever snapshots, and again, continue to enhance our single instance storage. We don't do compression and deduplication on the disk. However, with our single instance storage, we do see 3 to 4x the usable capacity relative to the number of VMs that are running. So we do really optimize the storage utilization. One of the big other features that will be out in the beginning of February, end of January, is our REST API support. So you'll be able to do everything that Karin showed you from a simple command line or PowerShell type of interface, and this will give you the ability to tie Ignite resource provisioning directly into any existing programs or scripts that you may have. We continue to enhance the user interface and put together different types of workflows based on what our customers are telling us and how they can best get value out of the solution. And of course, we're constantly updating the application marketplace. So actually just today, we released the Windows 2016 servers application template, and that's all of our customers now have that ready to go. So as I mentioned, you know, we have the application marketplace, but it doesn't preclude you from ever creating your own virtual machine out of any ISO or any existing VHD or VMDK file, so you can quickly ingest the data. So with that, you know, where can we get started? How can we help you? Well, a couple of things. As Karin mentioned, we have a virtual lab that we give you access to, so you can go right through the interface. You can click deploy applications. You can get a real feel of test driving the entire infrastructure, the entire cloud, without actually having to bring a unit on site. We do allow for proof of concepts where we can actually, you know, ship you a unit, but you'll have to talk with Chris and Karin about that with your projects, and we'll be happy to schedule a one-on-one demo. as well. So with that, let's see. We have a couple of minutes to balance out. So let's see, Tessa, are there any questions?
So one of the first questions was, do you have Windows Server templates in the marketplace as well?
Yeah, so we have Windows Server templates, including 8, 8.1, and all the current Windows Server templates, including, as I mentioned just recently, we just added Windows Server 2016 to the marketplace. They are sys-prepped. You do need to provide your own enterprise license key when prompted and installed. So you do have to provide your own license key.
Great. So the second question is, you mentioned about creating new IP ranges and routing for Cloudistics. Does this mean that extending existing VLANs or layer 2 networks into the platform is not supported?
I'll defer that question to Karin.
So it's not supported in terms of the VLANs themselves, but if we are connected, if our connection into a host network is into a specific VLAN, then the controls that are applied to that VLAN are applied to our entire platform. But those controls are not carried down inside the platform to individual groups of IP addresses. There's a big difference between the physical world in VLANs and the virtual world in VNets. So anything that is an IP-based ACL, firewall rules, routing, etc., those all get carried or applied to our traffic as it leaves our core and travels onto the host network. But in terms of actually extending VLANs into the Cloudistics Ignite platform, no, that's not possible. That would require us to have VNets and ACLs deployed inside the network.
All right, and just to follow up on that as a clarification point, our network virtualization technology is unique in that it actually virtualizes the network at layer 3 and doesn't use encapsulation technology, and that's what allows us to get the benefits of line speed network performance as well as virtualization. So it's different than a traditional NSX style layer 2 encapsulation and network virtualization. But great question, thank you for that. Tessa?
So one of the last question I think we have here is, what is the value of running big data applications like Hadoop on your platform versus AWS?
Well, so give you an example, we've been working with a couple of Splunk partners in the States as well as in the UK, and we have a couple proposals and presentations out for different accounts, and I can give you, there's really kind of two examples. So one is running Splunk on-premise on our infrastructure versus a different type of converged infrastructure, like a FlexPod, for example. When it's compared to running on-prem versus on-prem, our infrastructure versus a traditional infrastructure, we're about, I'd say, 40% of the cost, right, because of the performance and what we can do in the density. So there's a good cost savings there. However, Splunk also offers Splunk Cloud, which is their cloud-based service, for running Splunk inside their cloud, but their cloud actually sits on top of AWS as well. And when we compare licensing and services costs, we're literally about 70% less expensive. And one of the other driving factors, just to share with you, there is in some of the calculations, there's a component associated with the network bandwidth needed to push all that ingest data up into their cloud. So, for example, I think the base license, the first license has to go for 500 gigabits of Splunk, and I think it's recommended that you might see about a $5,000 per month. This is in the States, however, $5,000 a month type of networking bill to kind of move that kind of data up into the cloud. So hopefully that answers the question. So I think we've actually run out of time for this morning. So I guess what we're going to go ahead and do is thank you everybody for attending. If there's again any other questions, feel free to contact us. We're very excited, very honored that you spent the last hour with us and want to be respectful of your time. We will be sending out the announcement of the winner for the movie tickets here fairly shortly. And again, want to thank everybody for attending, and especially thank Karin for walking through the demonstration of the technology. Thank you and have a fantastic day, everybody. Cheers. Bye-bye.